Caye, a caye, or also spelled caye or key, is a small, low-elevation sandy island on the surface of a coral reef. Cays occur in tropical environments throughout the Pacific, Atlantic, and Indian Oceans, including in the Caribbean and on the Great Barrier Reef and Belize Barrier Reef. Etymology. The 1492 indigenous people of the Bahamas were called Lucayan, an anglicization of the Spanish Lucaos, derived in turn from the Taino Lucucari, which the people used for themselves, meaning people of the islands. The Taino word for island, carry, became cayo in Spanish and cay in English, spelled key in American English, cay in Belizean English. Formation and composition. A cay forms when ocean currents transport loose sediment across the surface of a reef to a depositional node, where the current slows or converges with another current, releasing its sediment load. Gradually, layers of deposited sediment build up on the reef surface. Such nodes occur in windward or leeward areas of reef, where surfaces sometimes occur around an emergent outcrop of old reef or beach rock. The island resulting from sediment accumulation is made up almost entirely of biogenic sediment, the skeletal remains of plants and animals from the surrounding reef ecosystems. If the accumulated sediments are predominantly sand, then the island is called a cay. If they are predominantly gravel, the island is called a matu. Cay sediments are largely composed of calcium carbonate CaCO3, primarily of aragonite, calcite, and high magnesium calcite. They are produced by myriad plants, e.g. coralline algae, species of the green algae Halimja, and animals, e.g. coral, mollusks, foraminifera. Small amounts of silicate sediment are also contributed by sponges and other creatures. Over time, soil and vegetation may develop on a cay surface, assisted by the deposition of seabird guano. Development and stability. A range of physical, biological, and chemical influences determines the ongoing development or erosion of cay environments. These influences include the extent of reef surface sand accumulations, changes in ocean waves, currents, tides, sea levels, and weather conditions, the shape of the underlying reef. Significant changes in cays and their surrounding ecosystems can result from natural phenomena such as severe El Niño southern oscillation in so cycles. Also, tropical cyclones can help build or destroy these islands. There is much debate and concern over the future stability of cays in the face of growing human populations and pressures on reef ecosystems and predicted climate changes and sea level rise. There is also debate around whether these islands are relict features that effectively stopped expanding 2,000 years ago during the late Holocene, or, as recent research suggests, they are still growing with significant new additions of reef sediments. Understanding the potential for change in the sediment sources and supply of cay beaches with environmental change is an important key to predicting their present and future stability. Despite, or perhaps because of all the debate around the future of cays, there is consensus that these island environments are very complex and somewhat fragile. Examples of cays include: the Florida Keys are composed primarily of exposed ancient coral reefs and light beds formed behind reefs. A few of the Florida Keys, such as St. Key, are cays as defined above. Heron Island, Australia, a coral cay on the southern Great Barrier Reef. Prickly Pear Cays, Angulo. Rama Cay, Nicaragua. Tobacco Cay, Dangruga, Belize. Warraber Island in central Torres Strait, 10-12, approximately 750 mx 1500 m 2460 ft x 4000 920 ft. This island is situated on the leeward surface of a large 11 km to 4.2 sq mi emergent reef platform. This cay and the surrounding reef flat are Holocene in origin, having formed over an antecedent Pleistocene platform. Elbow Cays, Bahamas. Great Goat Island, Jamaica.